Good day, math learners! In this video, we will talk about the multiplication and division of polynomials. Multiplication of polynomials. In multiplying polynomials, the distributive property of multiplication and the laws of exponents are applied. First, we need to recall the product rule about exponent, wherein it states that x raised to m times x raised to n is equal to x raised to the sum of m and n. And also, we have to use another law or rule wherein to multiply polynomials by another polynomial, multiply each term of one polynomial by each of the terms in the other polynomial, and then combine similar or like terms. Let us talk about first the first law of exponents, which is what we call as the product law. So in this law, we have x raised to m times x raised to n is equal to x raised to m plus n. So in other words, if we have this example, x raised to 6 times x cubed, since we do have the same variable x, therefore, we will be adding their exponents 6 and 3. Therefore, the result is equal to x raised to 9. The second law of exponents, which is the power of a power law, states that x raised to m is raised to another m, and that is equal to x raised to the product of m and n. So in this example, we have x cubed raised to 2, and that is equal to x multiplying the exponents 3 and 2. Therefore, the result is equal to x raised to 6. The third law of exponents, which is what we call as the product of a power law. xy is raised to m is equal to x raised to n times y raised to n. Meaning to say, we will be distributing the exponent n to each variable x and also variable y. So example, quantity AB raised to 2, and that is equal to a squared b squared. So distribute the exponent to variables a and b. Let us consider the first example. The quantity of 3x plus 2 times the quantity of 4x minus 5. First, we have to take the first term and the second terms of our first binomial factor, so that we can apply the distributive property of multiplication. So we have 3x here from our first binomial factor, and 4x minus 5 from our second binomial factor, 2 from our first binomial factor, which is the second term, and 4x minus 5, which is also the second binomial factor. After which, we will distribute 3x to each term of our binomial factor. So we have 3x times 4x. It gives you the result of 12x squared. 3x times negative 5, we have negative 15x. 2 times 4x, you have 8x. 2 times negative 5 would be negative 10. And then you look for similar or like terms. So you have negative 15x plus 8x. Since 12x squared doesn't have any similar terms, therefore copy. And then you combine negative 15x and 8x, therefore it gives you negative 7x. Then for minus 10 or negative 10, it doesn't have any similar term, therefore you copy minus 10. Therefore, our final answer would be 12x squared minus 7x minus 10. Second example, the quantity of 2x minus 3 times the quantity of 3x plus 1. In this case, we can also apply the FOIL method. And you have to take note that the FOIL method can only be used in multiplying two binomials. So FOIL method or FOIL stands for F first, O for outer terms, I for inner terms, and L for the last terms. So in this case, our first terms would be 2x times 3x. It gives you the result of 6x squared. O would mean outer terms. We have 2x times 1. It becomes 2x. I, inner terms. We have negative 3 times 3x. We have negative 9x. L, last terms. We have negative 3 times 1. The result is negative 3. Next thing that we should do is to rewrite this one in horizontal form so that we can identify the similar or like terms and then simplify. So in this case, our like terms would be 2x and negative 9x. Therefore, the result is equal to 6x squared minus 7x minus 3. Third example, the quantity of 3x squared minus 2x plus 4 times the quantity of 2x minus 3. So in this case, we will be distributing each term of our first factor to each term also in our second factor. So we have 3x squared times 2x. Then 3x squared again multiplied by negative 3. Let's proceed to the second term, negative 2x times 2x. Negative 2x times negative 3. Then for the third term, 4 times 2x and 4 times negative 3. And then simplify. We have 6x cubed plus negative 9x squared plus negative 4x squared plus 6x plus 8x plus negative 12. And then you look for similar or like terms. We have here negative 9x squared and negative 4x squared. We also have 6x and 8x. And then perform the indicated operations. So we have here 6x cubed. Copy 6x cubed since it doesn't have any similar terms. And then combine negative 9x squared plus negative 4x squared. It gives you the result of negative 13x squared. Also combine 6x and 8x. So it becomes plus 14x. And then copy minus 12. Again, it doesn't have any similar or like terms. So our final answer would be 6x cubed minus 13x squared plus 14x minus 12. Let's proceed to division of polynomials. In dividing polynomials, the laws of exponents and the distributive property are also applied. Let us now recall the quotient rule about exponent, wherein x raised to m over x raised to n is equal to x raised to m minus n. The fourth law of exponents, which is the quotient law. We have here x raised to m over x raised to n is equal to x raised to m divided by x raised to n is equal to x raised to m minus n. Meaning to say, we will be subtracting the exponents of the same variable. So we have here an example of x raised to 6 over x squared is equal to x 6 minus 2 is equal to x raised to 4. And that is the final answer. We also have the fifth law of exponents, which is the quotient of a power law. So the quantity of x over y raised to n is equal to x raised to n over y raised to n. Meaning to say, you have to distribute the exponent n to each variable x and variable y. Example, the quantity of 2a all over b raised to 4 is equal to, distribute the exponent 4 to 2 and variable a and also to variable b. Therefore, we have here 2 raised to 4, a raised to 4, all over b raised to 4. Since 2 raised to 4 can still be simplified, therefore we have here 16a raised to 4 all over b raised to 4. And that is our final answer. First example, 12x raised to 4 minus 10x cubed plus 4x squared plus 20x divided by 2x. To divide polynomials by a monomial, we have to divide each term of the given polynomial by the monomial. In this case, 2x here is our monomial. Therefore, we will be dividing each terms with 2x. So we have here 12x raised to 4 divided by 2x. Copy minus. So 10x cubed over 2x plus 4x squared over 2x plus 20x over 2x. So to simplify, we will be dividing the numerical coefficients 12 and 2, therefore that is 6. For the literal coefficients, we will be subtracting their exponents and copy the variable x. So in this case, there is an imaginary exponent of 1. So we have here x cubed, copy minus. So we have here 10 divided by 2, that is 5. Then for literal coefficient, so we have x squared, 4 divided by 2, that is 2. So we have here x as our literal coefficient. Then in this case, 20 divided by 2, that is 10. Then you can cancel x. And this is now the final answer. So the final answer would be 6x cubed minus 5x squared plus 2x plus 10. Second example, negative 49x cubed plus 42x raised to 5 minus 84x raised to 7 divided by 7x squared. To divide polynomials by a monomial, divide each term of the given polynomial by the monomial. So we have here negative 49x cubed divided by 7x squared plus 42x raised to 5 divided by 7x squared minus 84x raised to 7 divided by 7x squared. Divide the numerical coefficients. So we have here negative 7. For literal coefficients, we have to subtract the exponents of the same variable. So copy x, then subtract 3 and 2, so that is 1. No need to write 1 since 1 here is an imaginary exponent. So next term would be 42 divided by 7 for our numerical coefficient. So that becomes plus 6. Then since they have the same variable, so copy variable x, then subtract their exponent, so that becomes 3. Then divide negative 84 over 7, so that is minus 12. Then still copy x, and then subtract 7 and 2, so that is 5. As you have noticed, our answer is not written in standard form. So when you say standard form, you have to make sure that the given variable, the variables of the given polynomial expression should be arranged in descending order. So our final answer should be negative 12x raised to 5 plus 6x cubed minus 7x. So in this case, the exponents of our variable x is arranged from highest to lowest. Dividing a polynomial by a given binomial. In dividing polynomials by a binomial, the following methods can be used. So we have long division and synthetic division, or the shortcut method. So let us first begin with the long division. So in dealing with long division, we have to take note of the following. First, you need to arrange the polynomials, dividend and divisor in descending order of the exponent. Second, if a term is missing, insert 0 as a placeholder. So these are the following things that we need to consider in using the long division. Example number 1. Negative 2x plus 3x squared minus 4 divided by x minus 3. Step 1 would be to rewrite the given division problem in the form of dividend divided by divisor, with the terms of the divisor and dividend arranged to the descending powers of the variable. So, as you have noticed, our dividend here from the given is not written in standard form, or meaning to say, the exponents are not arranged from highest to lowest. So, in dividing, so we have to arrange it from highest to lowest. So we have here 3x squared minus 2x minus 4 divided by x minus 3. Step 2. Divide the first term of the dividend by the first term of the divisor to get the first term of the quotient. So in this case, our first term is 3x squared divided by x. So applying the quotient law of exponent, our answer would be 3x. So make sure that 3x should be aligned with the term of the same literal coefficient. Step 3. Multiply the quotient in step 2 by the divisor. So we have here 3x times the quantity of x minus 3. Apply the distributive property of multiplication. So 3x times x, we have here 3x squared. 3x times negative 3, we have here negative 9x. Then, step 4. Subtract the product in step 3 from the dividend and also change the sign of each term. So we have here 3x squared minus 2x. It is taken from this part here minus the quantity of 3x squared minus 9x. So distribute, that's why it becomes minus. Distribute again, so it becomes plus. Then simplify, therefore it becomes 7x. Then bring down minus 4. Step 5. Repeat steps 1 to 4 with the difference obtained in step 4 as a new dividend until the degree of the remainder is less than degree of the divisor. So we will take the first term 7x divided by x. So we have here again apply the quotient law of exponent. So this becomes plus 7. Then 7 multiplied by x minus 3, apply the distributive property of multiplication. So 7 times x, so 7x. Then 7 times negative 3, so that is negative 21. So we have here 7x minus 21. And then subtract. So when you subtract, do not forget to change the sign of the second polynomial. So we have here minus 7x. And this part here, it becomes plus. Then combine. So negative 4 plus 21, it gives you 17. And 17 here is our remainder. Step 6. We have to write the result in the form of. So we have this given. Dividend over divisor is equal to the quotient plus remainder over divisor. So the result would be 3x plus 7 plus 17 is our remainder over x minus 3, which is our divisor. And this is now our final answer. Another example, x cubed plus 2x squared plus 2x minus 5 divided by x minus 1. Again, step 1, rewrite the given division problem in the form of dividend divided by divisor, with the terms of the divisor and dividend arranged according to the descending powers of the variable. So in this case, as you have noticed, the exponents are arranged from highest to lowest. Then step 2, divide the first term of the dividend by the first term of the divisor to get the first term of our quotient. So applying the quotient law of exponent, so it gives us the result of x squared. Again, when you place the result, you have to make sure it is aligned with the same literal coefficient. Then step 3, multiply the quotient x squared to our divisor x minus 1. So applying the concept of the distributive property of multiplication, so we have here x squared times x squared times negative 1, so it gives us the result of x cubed minus x squared. After which, step 4, subtract the product in step 3 from the dividend. So when we subtract, we have here the quantity of x cubed plus 2x squared minus the quantity of x cubed minus x squared. So we have to distribute this operation here, or the sign. So it becomes minus, and this becomes plus. Then combine the similar and like terms. So there is an imaginary 1 here. So the result becomes 3x squared. Then bring down plus 2x. Step 5. Repeat steps 1 to 4. So we will be dividing 3x squared with x. Apply the quotient law of exponent. So we have here 3x squared divided by x, that is plus 3x or positive 3x. Then multiply 3x with x minus 1. So 3x times x is 3x squared. 3x times negative 1 is equal to negative 3x. Again, change the signs. This becomes minus, and this becomes plus. Combine similar or like terms. So it becomes 5x. Bring down minus 5. Then divide again 5x with x. So the result would be plus 5. Then multiply 5 to each term of x minus 1. So 5 times x is 5x. 5 times negative 1 is negative 5. Then change the signs. So minus, and this becomes plus. So that is equal to 0. You have to take note that a remainder of 0 indicates that the divisor is a factor of the dividend. Therefore, the quotient of our example is equal to x squared plus 3x plus 5. You don't have to use this part here since our remainder is equal to 0. Third example, 2x raised to 4 plus 3x cubed minus 4x minus 16 divided by x plus 2. We have to make sure that all terms are present. Like for example, we have x raised to 4, we have x cubed, x squared, x. But in our given dividend, it does not contain x squared as our term. Therefore, as a placeholder, we will be inputting 0x squared. So if ever there are some missing terms, we need to input 0, then the missing literal coefficient of the given dividend, so that it will serve as our placeholder. Then we will be dividing the first term, 2x raised to 4, with x. So we have here 2x cubed. After which, multiply 2x cubed with x. So we have 2x raised to 4. Then 2x cubed times positive 2. So we have here 4x cubed. It becomes negative here because we already changed the signs. So this becomes, from positive, it becomes negative. Then from positive, it becomes negative. Combine the similar terms. So we have here 3 minus 4, that becomes negative x cubed. Then bring down plus 0x squared. Then still divide negative x cubed with x. So we have here negative x squared. Multiply negative x squared with x. So we have x cubed. And then negative x squared. Multiply it with positive 2. So we have negative 2x squared. Supposedly it should be negative, but since we changed the sign, so from negative here, it becomes positive. And in this case, from negative, it becomes positive. So every time we subtract, there is always a change of sign. So in this case, we have 0x squared plus 2x squared, so that becomes 2x squared minus 4x. So where did we get minus 4x? You simply have to bring down. And then, repeat the same step. So divide 2x squared again with x. So we have here plus 2x. Multiply 2x with x. So 2x squared, then 2x times 2, we have 4x. Change the signs, so this becomes from positive to negative, positive to negative. Combine similar terms, so we have negative 8x, bring down minus 16, then divide again negative 8x with x, that's why you have minus 8. Multiply negative 8 with x, that's why you have negative 8x. It becomes positive here since we changed the sign from negative to positive. The negative 8 times 2. So in this case, it becomes plus 16 since we already changed the sign. From negative, it becomes positive. Combine similar terms, therefore, this becomes 0. So since there is no remainder, therefore, the final answer would be 2x cubed minus x squared plus 2x minus 8. Let's proceed to the second method in dividing polynomials. So we have here synthetic division. The process of long division is a tedious process due to its repetitive steps. So a shortened process called synthetic division can be performed in dividing a polynomial in x by a divisor of the form x minus c, where c is a non-zero rational number. This process makes use of numerical coefficients only and is illustrated using the earlier problems. First example, negative 2x plus 3x squared minus 4 divided by x minus 3. You have to take note that the polynomial should be written in standard form. So we have here 3x squared minus 2x minus 4. And we also have to look for x minus c, which is our divisor, that is equal to x minus 3. After which, we have to solve for c. So equate x minus c and x minus 3. Then solve for c. So in this case, transpose x. So we have here x minus x. Also transpose negative c. Therefore, it becomes positive c. X minus x is equal to 0. So we have here c minus 3. To compute for c, therefore c is equal to positive 3. So step 1. Write the numerical coefficients of the terms of the dividend arranged according to the descending powers of the variable x. So where did we get 3, -2, and -4? After arranging this dividend here, so that is written in standard form, 3x squared minus 2x minus 4. So we have to take the numerical coefficients of the terms in our dividend. So we are using 3, -2, and including the constant, -4. Step 2. Find C from the divisor. So a while ago we have computed C, which is equal to 3. And this will be our last entry for step 1. So we have here 3. So 3 here indicates our C. Step 3. Copy the first entry in step 2 to the third line. So we have here, so this would be our first entry, 3. So always copy the first entry to your third line. Step 4. Multiply the first entry to the third line by the value of C. Write the result in the second row of the second column. To illustrate, since you already have 3 here, multiply 3 with C, 3. Then you place your answer here, and that is equal to 9. Step 5. Add the entries in the second column. Write the result as the second entry in the third row. So you have here 3 times 3, that is 9. 9 here is positive. Since that is positive, therefore, that becomes -2 plus 9. The result is 7. Step 6. Repeat steps 4 and 5 until all the columns are used up. So we have here 7. Multiply it by 3, then place your answer here, and that is 21. Then add, so we have here -4 plus 21, the result is 17. The last number is your remainder. So the remainder in this given item is equal to 17. Step 7. Use the entries of the third row in step 6 as the coefficients of the quotient. The degree of the quotient is 1 less than the degree of the dividend. Therefore, you have 3x plus 7. A while ago, our last entry or the last number is 17. 17 is our remainder over our divisor x minus 3. And this is now our final answer. Second example. 2x raised to 4 plus 3x cubed minus 4x minus 16 divided by x plus 2. Insert 0 for the missing term for x squared. Since in our given dividend, there is no term for x squared. So as a replacement or as a placeholder, we will be putting 0. After which, we have to find the value of C from our divisor x plus 2. So x minus c, that is equal to x plus 2. Therefore, c is equal to negative 2. And then, get the numerical coefficients. We have 2, positive 3. As you have noticed, we don't have any term for x squared. So as a placeholder, we will put 0. Then negative 4. Then we will also include the constant negative 16. Then for negative 2 here, this is our c. Bring down or copy 2. Then 2 times c or 2 times negative 2, that gives you negative 4. So meaning to say 3 plus negative 4. The result is equal to negative 1. From negative 1, multiply it again with negative 2 and place your answer here. So that gives you positive 2. So 0 plus 2, it gives you positive 2. Multiply again with negative 2. So it becomes negative 4. 4 plus negative 4, that gives you negative 8. Negative 8 times negative 2, it gives you positive 16. So negative 16 plus 16 is equal to 0. 0 here is our remainder. Therefore, the final answer would be 2x cubed. We are using x cubed here since we have to subtract 1 from the exponent of our given dividend. So take note, in our given dividend, that is 4. So in this case, it becomes cube or 3. Minus x squared, we don't have to write 1 since 1 here is an imaginary numerical coefficient. So from 3, which is the exponent, so it becomes 2 plus 2x minus 8. So again, the final answer is equal to 2x cubed minus x squared plus 2x minus 8. Third example, 9x raised to 4 minus x squared minus 6x plus 2 divided by 3x minus 1. If the divisor is not of the form x minus c, but of the form bx plus c, divide both the divisor and the dividend by b. To illustrate, this is our divisor. The numerical coefficient here is more than 1, and that is 3. Therefore, we divide both dividend and divisor by 3. So to divide each term of your dividend with 3. So 9x raised to 4 divided by 3 is 3x raised to 4. Negative x squared divided by 3, negative 1/3 x squared. Negative 6x divided by 3, that is negative 2x. 2 divided by 3, that is plus 2/3. Same will follow to your divisor. 3x divided by 3, that becomes x. Negative 1 divided by 3, that is minus 1/3. And we will be using this part here. So we have here 3x raised to 4 minus 1/3 x squared minus 2x plus 2/3 divided by x minus 1/3. So as you have noticed, there is a missing term of x x cubed, therefore we are using 0 as our placeholder. Then 1/3, this will be the value of c. Then copy 3. 3 times 1/3 is 1. 0 plus 1, that is also 1. 1 times 1/3, still 1/3. Negative 1/3 plus 1/3, that is equal to 0. 0 times 1/3, that is equal to 0. Negative 2 plus 0, that gives you negative 2. Negative 2 times 1/3 equals negative 2/3. 2/3 plus negative 2/3, that is equal to 0. And 0 here is our remainder. So the final answer would be 3x cubed. Since in our dividend, the highest exponent is 4, subtract 1, therefore we are using x cubed. So 3x cubed plus x squared. As you have noticed, we have an answer here, 0. So meaning to say there is a missing term, which is the term for x. So we don't have to use 0x since that is already 0. Therefore, we simply have to place minus 2. So the final answer would be 3x cubed plus x squared minus 2. And that ends our discussion on multiplication and division of polynomials. Thank you.